Hello. Hopefully you guys can hear me. It's about five
Yeah.
o'clock. Okay, thanks. It's about 5 o'clock, so I'm just gonna let's just go get it started. So you can see here that there's this agenda here. So we're gonna recover the basic Python from last week. We're gonna finish covering Python. There's like one more thing. One second, I need it. Okay. And then I'm gonna go over some basic algorithms saying clock connect. Um, so Okay, so in last week we covered variables. Variables are very basic, just like integers, strings, booleans, etc. Like floats, if you want float. Like it's just basically different types of data that you can store in variables. And something that it's pretty self-explanatory. If you want to like print something out to the console, or it's like under this region, you just use a print statement. You can print anything. You can print like strings, print integers. Oops. You can print lists too. Yeah, it just allows you to like print any output out. So say if you just like we don't know what happens if we know the value of this data. We just print it out. Okay. Operations, there's addition, subtraction, multiplication, division. Like you're just a bunch of operations. I mean, there's nothing like too complicated about them except maybe modulus. It has a weird name, but it's just finding the remainder of the division result. So nothing special there. But something I wanted to go over again is equality. So like to equality results in a boolean, it's a true or false. So like is x equal to 5? That is true. Is x equal to 10? No, that is false. And yeah, that's how you can just check the if the value is equal to something. All right, that's just some functions lambdas. So you can see here that we have a function here. It's just x squared plus 1. You can you just can yeah, let's just control statements, just like if something something, you can do else if something something and else. And I'm just gonna rush through this because I'm gonna have some a few practice problems that I'm gonna have you guys do to check your understanding. And so let's go over all the data something that might be good to go over again is all the data structures and how to like use them. So a list is you indicate a list with square brackets. 1, 2, 3. You can index something by specifying which position. And remember, lists start from 0. This is the 0th element, this first element, and the second element. So make sure you guys just keep in mind that lists a lot of data structures start at 0. So and you can reassign a value. So if we can override the value of the first value, and then we can add another value. To add a value to a list, you do a.append, and that's how you add a value to the list. And if you forget, you can just easily just like go into Google and just search how do I add a value to the list, and then you'll probably find some Stack Overflow post or some documentation that'll tell you how to do this. And dictionaries, dictionary is just the list of key value pairs. You can key the dictionary to get the corresponding value. So d equals a1 b2. So this might be let's actually do ages. Bob, he's 30, he's 40, Joe 20. And so you can so like what's the age of Bob? You just do that and then you can get 40, right? And that's the dictionaries. And tuples, just remember that they're basically lists, except you can't change them. Once you create a tuple, you can't change the underlying tuple. the in operator. So say we have like a list 1, 2, 3. It also results in a Boolean. So A in 1 in A. That is true because this A has a 1, right? Well, if we try to just check if 4 is in A, that's false. And we can do this again with a dictionary. And the in works for the key, it's applied along the key. So A in D. And so something to keep in my mind is even though that there is technically a 1 in the D, it is as a value. So if you do 1 in D, it won't show up. So what we can do, we can just do dot values to get the values, and that returns it in a collection, like a list or a tuple, like list. These are like collection data structures that hold a bunch of different elements. So not exactly a list, but it's very similar. And so we can check if 1 is in the values. And so we can also do like, this is basically what it is in the keys. But with the in keyword, with the in operator on the dictionary, the dot keys is sort of like implicit. And so if we do this, we'll get the same answer. Okay. For loops, remember to do like if we wanted to iterate from like 1 to 10, I mean 0 to 9, we just do print I. And then we can do the same. So for I in range 10, and range is basically sort of like it just range, it sort of like makes the list up to that index, up to but not including that index. So this is what basically range looks like. Range 10. It's not exactly a list, but it's basically a list. It's basically very similar to a list. It's just like another collection, like a list or a tuple. Okay, so and how do we do this using a while loop? So that equals 0 while I is less than 10, and this is a Boolean condition. So print I plus equal to 1. And if you remember, this is equal to I equal I plus 1. Okay, and that gets us the same thing. And listed dictionary comprehension. So basically allows you to just iterate over, like create a new data structure and iterate over the old data structure and do some operation or whatever on the left here and store it in here. Oops. And so let's create a list of everything. So list range 10. Okay. So let's just create a list of 10 elements, and we want to keep. Let's keep everything that's that when you divide it by 3, you get 1 as a remainder. Okay. So for I in for A, what we can do is add another condition. We can add an if statement if something is true or false. So if that I element that we're iterating over A with, if you mod 3 and it's equal to 1, then let's see what we get. And you can see that if you divide 1 by 3, the remainder is 1. If you divide 4 by 3, the remainder is 1. If you divide 7 by 3, the remainder is 1. Okay. And then what happens? We can even add another operation here. So we want to get everything that divides 3 and gets a remainder of 1, and then we can add 1 to it. And you can see here, this is exactly what we expect. It was 147, now it's 258 when we just added 1. Okay. And so I have a few exercises here. So the first, so you guys can try like you guys can, I don't know if you guys have like Collab, just like simply just create like, I think you can log in with your Google account or something. So I want you guys to create a Collab session. Just go to collab.com, Collab Google or something in the search bar, and then just go, and then like create a new what do you call it, a new notebook, and then like try to do these exercises. So I'm gonna give you guys like 5 minutes to do that. And feel free to Google I mean, maybe like not Google something exactly, but Google something like more general, like and then like just apply what you Google. It's good skill. Okay, hopefully you guys had some time to think about it. So if we take a oh shoot, that's the answer. Okay, delete that. If we take a number and divide like an odd number, so 5 mod 2, we get 1. Or like any odd number, 7 mod 2, you get 1. Anything mod 2, you get 1. It's because when you divide a odd number by 2, you always get a remainder of 1. And if you divide a even number by 2, you always get 0. So that's how we can tell if it's gonna a number is gonna be odd or even. Okay. Okay, so the first thing we need to do is let's just try to get a list where the numbers are just from 0 to 10. Doesn't matter if they're odd or even. Okay, so let's do I for I in range 10. That's our first try. And so the first issue, so this is a good attempt, but it's 0 to 9 and not 0 to 10 because as you remember, range is how many numbers there are from the list starting from 0 not the largest number of the list. Okay, so the first thing we need to do is fix that by putting 11 so that we go 0 to 10, okay? And then so we're halfway there, okay? And now we want to get the numbers that are only evens. So if I mod 2 equal 0, okay? And now we got evens. And then the last part, it says to store it in a variable called evens, okay? Okay, so next, how do we create this using a for loop? So first, let's create an empty list called evens. Then for I in range 11, for the same reason we explained earlier, even if we want to check if it is even, if I is even. So how do we check that? We mod 2 and check that is equal to 0. Then, if you remember earlier, we use append. We append stuff to list. So evens. And then let's check out this evens, okay? And, oops, not meant to append the I. Okay, so now we have that, okay? Hopefully that wasn't too tricky. Okay, so next we want to square all them elements in the list of evens. And then so we can use another, so let's just keep this evens. And so let's do evens square equals something. Let's just put it like like A or something for A in evens. So we need to do something to this A to make it squared. We can just apply the square operator. And then we get the evens square. Oh, oops, I misspelled that. And so you can see 0 to squared is 4, well, etc. Hopefully that wasn't too tricky. Okay, so now we want to loop through the list of evens and print AAA if the number mod 3 is 1, else print BBB. So for A in evens, we want to check if the A mod 3 is equal to 1, then we print AAA, else print BBB. And so we get exactly that answer output, okay? Are there any questions? Hopefully that wasn't too tricky. Okay, sounds good. It doesn't seem like anyone has any questions. Okay, let's go over what classes are. A class is a sort of like a data structure. It is an object. Well, no, class. A class is like a template that you use to store like it's sort of like an abstract thing, like a person or like an animal or something, or it's like an object. Think of like objects, like to run is like sort of a verb, and verbs are sort of like functions. So but a class is collection of variables and functions. So let's give an example. So let's create a class called person, and this is just gonna be fun. Okay, so that so let's do def init, and this kind of looks confusing. What does init means? Init stands for initialize, and this gets called when we create a person object, and we'll create a person object later. Okay, and then we have self, and then self refers to the instance of that person. So say we create a person called Bob, then every time we can use a self that variable, and that self would be Bob. And so what are some like characteristics of a person? Can someone give me some example characteristics, like variables that contribute to a person? Other type in the chat. Height, age, good. Younger. Net worth. Name, yes. Okay, so that's a good list. Thank you, Parker. So name is probably the most important thing to a person because it identifies them. And then let's do age, because age, like height. I mean, age is a nice number. Like 17. If you're 17, you're 17. But if you're like 6, height. If your height is 6, like 6 what inches, foot, whatever. And so let's not deal with that for now. and then let's is married, and so let's just get the spectrum, and then like salary, and then so we want to store it to that person, so self.name equals name. Okay, this kind of looks really weird right now, but it'll make sense more later. Self is married. Let's first name. Let's give him a first name and last name. Something later. Oops. And let's make this a male. Male person. This like why am I doing this? You'll figure it out later. Is married. Okay, so now we've created a person. Okay, so how do we initialize this person? So we're gonna do let's name him Steve. Okay, so let's create an object person called Steve, and male person is this is, we don't have to pass this self in, so this is basically if we passed in Steve, like it passes itself. Actually, no, I'll go over it later. Let me explain the self thing later. One second. Let's go over this first. So his name is Steve. His last name is Jones. So let's make him Steve Jones. He is 20, no, like 25. He is married, true, and he makes like 100K. And let's run it. Okay, so you might your first thought might be like your first thought might be, it was like 1, 2, 3, 4, 5, 6. There's 6 arguments. Yeah, I passed 5 things. What is this? And it's related to the self. And let me just go over that after I go over what the hell say name. Let's create a function called say name. Say name. Self. Okay, so let's print hello. My name is my name is first name, last name. Oops. And so now let's have Steve Jones say his name. Oh, I forgot to put the self dot. Okay, now it works. Okay, so what happens if we want to make it say first name, last name. So if not married, else say Mr. last name. Does anyone have an idea on how we can do that? It starts with a C. That's a good question. Are fields public or private? All Python fields are public, unless you, by default. What? Dot operator? What's a dot operator? What are you talking about? Steve dot name? Yeah, that's a, yeah, Steve. Yeah. We can do Steve dot name, Steve Jones dot name. We can access it like that. Is that what you're asking? Yeah, we use the dot operator. Oops, first name. So so to make a field private, what you do is just do self dot. Let's like legs, and then let's try to access this legs variable. I think it might work. Is this legal? Nope, it's not legal. And so that's how you create a private variable. You just put 2 underscores in the front. Python used to not have this not all this, but I think it's pretty new. Okay, so let's go. So right now we say first name, last name by default, but how can we do first name dot say first name, last name if you're not married, and then say Mr. last name if you are married? Does anyone have an idea? It has something to do with logic. It starts with a C. C-O. Anyone have an idea? Okay, maybe let me scroll up and see. Let me scroll down. Yes, that's correct. Conditional. Okay. So yes. So can someone tell me what I should do? What should I put here for the first conditional? First line.
If Steve Jones is married.
Well, how do I do that?
Huh? If
is it Steve?
If Steve Jones is married or not, so it'd be the exclamation mark.
Oh, well, it'd actually be self dot is married, not Steve.
Oh, are you writing? Oh, I thought this was outside of the function. Sorry.
Oh, that's no, yeah. I should have specified that. Say in there. Okay. Yeah, but that would work if it's outside the function. Okay, so else, yeah, it's just self dot. Okay. So let's try this when Steve Jones is married. Oh shoot, I forgot the Mr. And so when we set the married to true, it says Mr. Jones, and then let's do false. And then now it's Steve Jones. Okay, hopefully that makes sense. And so the self is basically if you did self.save name Steve Jones. This is what it's doing, right? Because the self is just this object here, okay? It's just this object as variable. So, but we call it self just in case like we have some new person called Bob Jones. So just keep it self to make the variable name generic. And so, but what Python does is it automatically passes when Steve Jones.say name, it automatically passes itself as the first argument no matter what. Well, there's a way to really like make it not do that, but let's just ignore that for now. So this is basically what it's doing implicitly, okay? Hopefully that makes sense. And so when we do self dot first name equals first name, because like outside the scope, these variables disappear. So how can we keep him like store it? We can do like we can store in this Steve Jones here, right? Self dot first name equals first name is store it into this object here, okay? And then when we want to access a variable, we can do self dot. And so you might be thinking it's like it's sort of like this keyword in Java or some C++ or some other language, okay? But you must use it. Like in Java, it's sometimes optional. It's most of the time it's optional to use this dot. It's but in Python, it is not optional to use self when you want to access a class variable or function. And so we can even put this function in here. Like we can. So if we want to say name when we create a person, just say self.say name in here, and let's just do this. And so we can call other functions in here. Okay. Hopefully that makes sense. And so let's create a new person called class programmer. And let's have him derived from a male person. Okay, I'm not trying to be sick. No, I'm just kidding. Okay, programmers can be females. Just to clear my name here. Okay, all right, let's put male programmer. Sorry. Diff init. Self first. Let's just copy this. Okay, so what's something that's can we attribute to programmer? Let's create a new field for a programmer. Beyond what is a typical person. Like what is something that might be specific to a programmer? Well, it doesn't have to be like it was like somewhat specific. All right, let's just put favorite programming language, like fave language. It could be like Java, Python, or whatever. So what happens if we want to just keep all this stuff here? We want to use this, so we can do called superclass. This because male programmer inherits from the male programmer inherits from a male person. We have access to like we have access to this function in it here, and we have access to this function here. And so let's, but this isn't called automatically. We need to call it. We have to directly call it. So male programmer is a subclass of this male person, and the male person is a superclass of the male person. So that's why we do super dot init, and then let's just pass in all these the default ones. Pretty sure that's how you do that. Is this it? I can't remember. Let's make him a male programmer, and his favorite language is Python. Oh yeah, that's correct. No, is it correct? Oh, shoot. Oh yeah, it's working now. Oh, let's print it out. Okay. And let's create a new function called program. Program. So, and then let's give it some. Let's create a new. And then let's just print out. Blah blah blah. We can do whatever. But for this, let's just say, I am now am now programming in language, in whatever language. And so let's have this Steve Jones program in Java. Oops, I forgot the self dot. Okay. And we because we inherit, we also have access to like this like whatever was also in the sub super class. So we can call say name. Okay, let's just delete this for now. Let's not have him say it. Okay, yeah. And so we can access other stuff like name, first name. And something we can do is override a previous function in the superclass. So say we want to have this programmer say name, but we want to have it slightly modified. So let's just def say name self, and then let's have him say my name is first name self dot. I forgot the self dot first name self dot last name. And my favorite language is, and then self dot fave language. Oh yeah, and so using this stuff here, like using this model here, this right now, if we do say name, it will give us an error. Can someone tell me why this will give an error right now? Yes. So this code right now would not work if we ran it right now. You don't have an idea? Like look up here, like do you see this like self dot first name equals I just gave it away. Okay, the reason this won't work is because we haven't stored this this fave language to this self yet. So self dot fave language equals fave language, and fave. Okay, let's just comment this out and see what error we get. So male programmer has no attribute fave language. So let's make it attribute. Okay. And if we even if we have it in the superclass, let's just put this self.say name back here. Even though like there's the same name here, we'll use the overridden function. So let's just come to that. Oh wait, that won't work actually. Oh wait. Yeah, because we need. I think we need to assign this first. Oops. Because we were trying to call that function before this thing was set. Okay, there. Now it works. It'd be the issue is that we didn't set this self.fave language. So when we were doing this, go here, this fave language wasn't set yet. So we need to set it first before we do this. Okay. And so now you can see that we're using the same name of the male programmer, despite this being in the male person, okay? Because we overrode the same name. So everywhere we use it, we can do it like that, okay? Hopefully that all makes sense. Do you guys have any questions? Is there any confusion on anything? Or do you got like any questions on like see the chat? Okay, it doesn't seem to have any questions. Okay, so let's give another example of the usefulness of classes. Say let's create a class SAT, and so def init. So self test taker. No, how about student ID? We can be lazy. And so there's like a reading like English score, I think math. Self.student ID SAT score. SAT score. 1, 2, 3, 4, 1. Yeah, self by English. Wait, no, never mind. English equals English. So self dot math. Score. So let's just create. So. Oh, these are fake numbers. Unless you guys really want to know my SAT score. Okay, so now we can okay, and then let's do like def compute score, No, actually, let's do compute percentage, PCT. Like what percent you got on the SAT? Like 100% correct. And then let's do like out of, and you know the SAT could be out of 1600 or it could be out of 2400 based on what you take. And so we can return self.english plus self.math divided by out of. And so while we could well, let's do that. Okay, so while we could store the SAT scores in a tuple, let's just do like my score. My score equals, just copy these things. Like where this first value is the student ID, this is the English and math. However, one issue with this representation of data is just that like you have to keep track of this. You have to like write it down. Like first index is student ID. Second is English score. Third is math. And you can see now this is tedious. And every time we want to use this my score is like, I want to get the math score. What index is that again? 2, 1. But if with this other my score, if I want to get the math, I just do .math. It's like there's no confusion, right? And so that's that's another benefit of classes. It makes data, you can store a collection of like data things, like something that has multiple points of data, like a math score, English score, in one data structure thingy, and have everything not be ambiguous. And then you can define a common set of like functions that are helpful. Okay. Hopefully that shows why we use classes. Okay, so let's skip over this panda stuff. Let's go over some basic quick NumPy. Oh yeah, this is how you do import something. So like if you want to import a thing, do import the library, and you usually want to run pip install. Like if you're using, it depends on what operating system. I use Linux. I use Ubuntu, so I do pip3 install NumPy. Well, you have to make sure you have to have pip installed first. So you do sudo apt. Well, this is for Ubuntu. It depends. You can just Google how to install pip on Python 3 pip. Okay, and then you install it. I already have it. I'm not gonna install it, but Google Collab. If you use Google Collab, it already has a bunch of like pandas, matplotlib, keras, scikit-learn. It has a bunch of like useful like scientific computing, because like these Collab notebooks are usually for like machine, like when you want to do data science or machine learning stuff. Well, today we're not doing data science or machine learning stuff. It comes with all the stuff, but you can, if you want to do something like Yahoo Fin, if you want to install some like new package, you just do that thing. Put a exclamation. Well, you don't need an exclamation anymore. Just do pip install Yahoo Fin or whatever library you want, and then just run it, and then it'll install it into your notebook. You might have to restart your runtime. So restart your runtime. Well, I actually have a prompt, and then it'll reload the notebook once it's installed. And so we can use NumPy as this, right? NumPy.array, and let's create an array where it's just 1, 2, 3, 1, 2, 3, and let's just look at this. Okay, so we just have it right, but NumPy programmers are lazy. Yeah, so we don't want to type out the entire NumPy. We can change it to something else, like MP. Oops. MP. And now it's the shorthand. We can do MPA if we wanted. Like it doesn't make, I don't know why anyone would do MPA. But when you do the as, it renames the library. Okay. And so why? Okay. Why should we use? And so we're dealing with matrix. Does anyone have an idea why we're using this NumPy array, NumPy library, instead of using like a list of lists? Can someone give me an example of some like operation between matrices that would be like very painful if we try to use lists instead of like some pre-built package? Yes, that's just correct. Yes. Basically any matrix, any matrix operation that is specific to matrix would be nearly impossible to do with regular lists and stuff, because, well, it wouldn't be possible. It'd be very tedious and annoying and all these educators. So we can just use a pre-built library. So to this, okay. 1, 2, and then let's just create a 2D array. 1, 2, 3, 4. And it seems like you guys know what matrices are, which is good. So hopefully, let's create a 2-dimensional array. And let's create another ones array. And then let's multiply. Okay, so this won't actually get us what we want. Okay. Actually, I'm not. So you can see that when it doesn't give us the correct answer, like what the result would be. Is oops. It'd be like what? So if you do this multiplication 1 time, let's print out x at once. Print x. And so when we multiply, do this matrix multiplication out, what we want is like 1 times 1 is 1. What 2 times 1 is 1. It's like 1 times 1. This 2 times 1, and then we add that together, and then we get 3. And then we do that again 3. We go to the next, and then we get. So then we take this 4 multiplied by 1. 4 multiplied 3 multiplied by 1, 4 multiplied by 1, and then we get 7. And then 3 multiplied by 1, 4 multiplied by 1. And we add those, we get 7. And so that's the result we want. And actual result, actres equals, but our result are, this is okay, actually. However, when we use this regular multiplication, that's not what we're getting. We're not getting 3377. And that is because when we use this star operator multiplication, what it does is it's element-wise multiplication. It multiplies this one with this one and puts it in the array. The multiply this 2 with this 2, puts it in the array in the same location. 3 to 1. Okay, so that's what it does. And to get the correct multiplication, we have to use matmul. So linalg.matmul, and then we will get. I can't remember. What's it called again? Shoot. I'm pretty sure. Oh, there's no linalg in front. Okay, now we get the correct answer. But something you can also do is use the at. It kind of looks weird as like at. What does it have to do with make the multiplication? It's like I don't know, but whatever, just use it, and that'll also give us matrix multiplication. Okay, hopefully that all makes sense. And there's a bunch of nice things with NumPy. Like, so what happens if we want to get the uniform okay, so we all know what hopefully you guys know what a Gaussian distribution is. Basically it's bell curve. But what happens if we want that bell curve to not be a bell curve? What happens if we want it to be flat? And so what we can do is just so let's just create like 100 data points of numpy.random.rand. Actually, let's just generate 100 values. Okay, so let's import pyplot as plt. Well, we're gonna use this plt to plot something. So let's just look at what this d looks like. And it's just an array of 100 data points, okay? And so let's plot this plt.hisd. And let's get, oh shit, I'm not sure. Wait, no, rand, no, this is like, oh no, it's normal. Oops. 0, 1. So this is the mean. Okay, so this is the. I can't remember. I think this is. Okay, there we go. Okay, so this is the mean. This is the standard deviation, and this is the number of data points, and then. So it's basically Gaussian distribution. You see this bell curve, and to get to a uniform distribution, where you just do rand. Oops, no. I have to get rid of this other arguments, and it generates us 10,000 points of 10,000 points of. Actually, no. Okay, ignore this rand thing. We're gonna use -1, and this is how we're gonna generate. We want to. Okay, now we have uniform distribution from 0 to 1. I mean -1 to 1. Okay, we're gonna use this later. And so, how can we calculate? So say we want to know the value of pi, and like say we don't know it's 3.14, and we want to estimate the value of pi. And so I'm just gonna guys have. So what we can do is we can. Like, while we can't get the exact value of pi, we can get a pretty good estimate via some simulation. And if you can remember from math class, a circle is represented by x squared plus y squared equals r squared. And let's just have the r equal to 1, the radius equal to 1. And so 1 squared is 1. And a point, if represented by the coordinate xy, our point is in the circle if x squared plus y squared is less than or equal to 1, okay? Because x squared plus y squared equal to 1 is on the circle, and anything less than that 1 means that the distance from the origin to that point is within that circle, okay? And say we have a bunch of like 10,000 points and we just randomly put it into that. And then we also have this square right here, right? And each side length has a length of 2, right? Because from -1 to 1, so 0 to 1 is 1, okay? But -1 to 1 is 2. So each side is a length of 2, okay? And say we just put a bunch of random dots on this place anywhere, but let's just put in this. Let's just confine it inside the square for now. And so the ratio of dots inside the square to the ratio of dots inside this, inside the circle to the ratio of dots inside the square is roughly equal to the area of the circle to the area of the square. And that should make sense, right? Because this is the area of the circle, and then this is the area of this, and then all this, including the circle, plus these corner edges thing here, is the square, area of the square. And so, does that make sense? Yeah, hopefully that should be pretty intuitive. And so let's go to this, and we see that it is not exactly, because there's a bunch of randomness, right? And so we might be slightly off, but we'll get a pretty good estimate. And so and then the area of the circle is pi r squared, and then this r, and we're trying to solve for pi, okay? And pi, so like, let's just say pi is our unknown variable, and that's a variable we're trying to solve for. So pi r squared, we know the area of the circle is pi r squared. And then we also know the area of the square is 2r, because this is 0 to 1 is r, length of 1 is r, but because we need 2 r's to get the entire side of the square. So this is r, and there's another r. So 2r squared for the length, well, 2, and then we simplify it, we expand it. So pi r squared over 4r squared, pi to 4. And then what we could do is multiply the 4 over to, so 4, and then to estimate pi, okay? Does that all make sense? That's our mathematical stuff, mathematical derivation for the formula to get pi. So to simulate pi, what we can, to find pi, to estimate pi, well, I should have said estimate, not exactly find. We can simulate 1,000 points inside the picture square, count the number that landed in the circle, and then plug into a formula. So we plug in 1,000 here, number of points in the circle, and then we multiply by 4 to get an estimation of pi. Okay, so let's just, okay, this is the answer. Let me delete it. Oh shoot, I forgot to go over something. Okay, so to go to this, a nice thing we should go over is zip. Let's go over back to the data structure. Okay, so let's create 2 things. Let's 1, 2, 3. Let's say these are x values, and then we have, oops, and these are, we have a bunch of y, we have a bunch of x, y coordinates. So equals, and then let's say 1, 1, 5, and so we have a 1, 1, 2. So this would correspond to the coordinates of 1, 1, 2, 1, 3, 5. Okay. And so how do we get that into a list? So what we can do is we can use the zip operator. What zip does is it's sort of like a zip, like a zipper. Like you get the first thing from one side, then you get the second side. So x values and then y values. And let's just put it into a list for now, just so we can see what it looks like. Because if we just did the zip, zip x values, y values, it'll kind of look weird. It could be some weird zip object, but let's just put it into a list for now, just so we can see what it looks like. And you can see it's exactly this way. And so while we could have represented this points initially points list, PTS list equals whatever here. What happens if we're doing some like leak code, or we have some like what happens if we're reading some file and it gives us the x values first? Like there's a bunch of reasons why we might not get this initially, why we get the list of x values or y values. And And like say we're doing some different problem and it's not like XY coordinates. So what happens? I can't think of an example off the top of my head, but zip basically just takes the first value and then puts in here and then takes the second value. I'm pretty sure you can zip. I'm pretty sure. I'm not. I can't remember if they do this or not. I think you can zip. Yeah, you can zip like a bunch of stuff together. But here we're just gonna zip two collections together to get these XY pairs. Okay, so and then we can. Okay, so okay, let's go back down here. So that's our. So let's simulate a bunch of. Let's simulate a bunch of X values. So let's do X value. Where is it? Well, let's take this. And then let's simulate a bunch of Y values. Let's copy this again. And we're doing negative. So we're doing a -1 to 1, and we're simulating 10,000 values. You can see here -1 to 1. That's and so we simulate like some random X coordinate, and then we simulate some random Y, Y coordinate. Okay. And so we've just simulated a bunch. So with this code, we've simulated a bunch of X values and Y values. Okay. And so let's just plt.plot X values, Y values. No, actually do scatter. We can let's make this 100. Just like it. And you can see that we have a lot. We just created a bunch of random points. Okay. And so let's iterate over this X and Y values as coordinate pairs. So for X comma Y, this is how. Let me go over this real quick. So we can iterate stuff over like unpack it into tuples. So this is called unpacking. So say we have a tuple called or a list or some collection. So let's create a like A equals 1, 2, 3. Let's do X, Y, Z equals A. And what it does is then it packs the value, sets the first value to this X equals 1, Y equals 2, and Z equals 3. Okay, let's just look at this. And Z is 3. Okay. And so what happens if we try to unpack 4 values, W? We'll get an error because there's 3 values here, but we're trying to unpack 4 values, and that doesn't make sense, right? You can't get 4 values out of 3 values. And then we can apply this to iterating over something. So like so let's just print list zip 1, 2, 5, 6. And let's just store this into a variable called D. And so how do we iterate over this, like these two pairs? We can do X comma Y. And so that does it, packs it in D, print X, print X comma Y, okay? And so we can do the same thing here. So we iterate over, so we iterate over the zip. Let's do this again. We zip together the X and Y values to get them into like a list of coordinate pairs. X values, Y values. Okay, then we want to if something. Okay, so actually let's create a variable called square count to count how many there are in the square. And let's just make it 1,000 square dots. And then let's create a variable called circle.count equals 0, and we're gonna keep adding it to this. Okay, so someone tell me how we check if this XY pair is within our unit circle, within our 1 radius circle. You can write an equation or something, I don't know. Or you can like unmute yourself and say it out loud. You know what idea? Like, how do we tell if, or so let's go back to this picture. So say we have an XY coordinate. How do we tell? How do we tell if one of these dots or coordinate points or whatever is inside our circle of radius 1? Yes. Okay. I think that's about right. So what we can do is we can take, okay, so we can, the answer is actually right here. X squared plus y squared is less than or equal to 1. So that's how we can tell. So we're going to check if x squared plus y squared is less than or equal to 1. So so if x squared plus y squared, and remember this is the square, this is the power operator, so y to the power 2, x to the power 2, and that's basically the square, is less than or equal to, oh yeah, I forgot to go over, yeah, I need to operators, equality, oh yeah, equality, oh yeah, let me go over, so this is another type of, so this is less than or equal to, and this is greater than equal to. Okay. You can also just do greater or less than. I mean, it's just basic, like math equality operators. It's nothing too special. Okay. So we can check if x squared plus y squared is less than or equal to 1. Then what we can do is circle dot count, and if this is true, then we can increase the value of circle dot one count by 1. And okay, so now we have everything we need. So can someone use these variables and type out the equation to compute the value pi using this variable, square dot count, circle dot count. And let's go back up here using that. Can someone type it out using like Pythonic computation of pi? Let's just like have it say like pi equals or something. So pi equals something. Okay, so can someone? That is correct, and let's do that. So 4 times circle count. And because of PEMDAS, we don't actually need the parentheses if we're lazy. Oops, circle dot count. I forgot the end. And you can see here that we get a pretty good estimation pi. Let's increase it to like a high number. And you can see that isn't that pretty cool? Okay, now we have simulated pi. Okay, are there any questions so far? I mean, does anyone have any questions? Any comments or no? Okay, hopefully, is there any topic you guys want me to cover again? Okay. So I'm scrolling down. Tell me if you have any questions. Okay, so let's apply the lambda. Okay, so let's create a, no, actually, no, that won't make any sense. Nah, let's not put the lambda in. Okay, I was planning on going over some quant connect stuff today, but this took a while longer, so I'm just gonna end it here. Anyone? So if nobody has any questions, I'm gonna end the meeting, and hopefully you guys had a good day. Hopefully you guys found this cool. Like we simulated pi. We simulated pi using like we're not using any like super fancy technique, just based on some basic random number generator and some basic equations, basic like middle school math equations. Like we didn't use no supercomputer or anything, and we can simulate pi. Yeah, this is basically what a bunch of supercomputers do. I think. I'm not sure. I'm not actually. So it's called, this is called a Monte Carlo simulation. If you guys want to look what this is up, and it's just basically using randomness to simulate stuff. And so something that you can use this for is you can simulate random stock data, like have and then run that through a backtester. And so this is something that Ernest P. Chan does to like optimize parameters like for the straight out. And but the so this is what this. Okay, so nobody has any question. I'm gonna have I'm gonna have a meeting today. For reach out to me, shortone1 at gmail.com or my school mail. I don't know, it doesn't really matter. Or you can just Google my name or something. You can Google ATC and some find it. If you have any questions on this or anything, feel free to reach out to me. I'm gonna end the meeting. Have a good day, everyone. Okay, bye.